Welcome to this lecture on. In today's video, we are going to study an important sensor used in modern automotive systems, the steering angle sensor, also referred to in this presentation as the steering position sensor. The steering angle sensor plays a very important role in determining the actual position of the steering wheel and consequently the direction in which the driver wants to vehicle to move. In this lecture, we will cover steering angle sensor, fitment, design and function, working principle, measuring principle, true power on or a TPO, functionality, Hall effect based steering position sensor advantages, Poka-Yoke connectors, sensor test standards, electrical protection circuits, and finally the steering position sensors summary. So let's begin. First, let us understand the fitment or mounting location of the steering angle sensor. The steering angle sensor is associated with steering column and steering wheel. As shown in the figure, in this diagram, the sensor is mounted around the steering column so that it can detect the rotational movement of the steering system. The basic purpose of this sensor is to measure or determine how much the steering wheel has rotated and in which direction it has rotated. This is the main two reasons. This information is very important for several electronic control unit systems. The sensor therefore acts as an interface between the driver steering input and vehicle's electronic control system. Now let us look at the design and function of the steering angle sensor. The sensor uses a gear based arrangement. The figure shown below. The sensor uses a gear based arrangement to determine the steering angle. The presentation shows gear wheel with different tooth arrangements. The difference in the number of teeth between the gear is important because it allows the system to determine the angular position more accurately. The rotational movement of the steering column is transferred through the gear arrangement. The sensor then measures the corresponding angular position. This principle allows the steering angle sensor to measure the actual steering position. Okay. Now let us understand the working of steering position sensor. The steering angle provides information about where the driver wants to vehicle to go or move. For example, when the driver turns the steering wheel to the left, the sensor detects the corresponding steering movement. Similarly, when the steering wheel is turned to the right, the sensor detects the movement in the opposite direction. The steering angle information is not used only for steering control. Okay, it is also used by other vehicle systems such as steering stability system, stability program, that is also called as ESP, and active front steering. It is one of the feature that is called as AFC, and adaptive front lighting, that is called as a AFL. and other electronic vehicle systems. Therefore, the steering angle sensor is an important input sensor for modern vehicle control systems. Another important feature mentioned in our previous presentation is true power on, that is called TPO functionality. Normally, when an electronic control system is powered on, it needs to know the current steering position. Therefore, it is important for the system to measure the steering angle value immediately after power on. Okay, the steering angle sensor provides this capability, this information also. The sensor is mounted on the steering column, generally within the passenger compartment. This sensor have an ability to determine the steering position at power on is called true power on functionality, that is called TPO functionality. This is particularly useful because the vehicle control system can immediately get the information, obtain the information about the steering position. Okay. Now let's look more closely at the working principle. The module consists of 3 gear wheels. The central or hub gear wheel is mounted on the steering column. This is shown in figure. Please refer. This hub gear represents the steering angle, which is represented by the symbol pi, phi. There are also 2 similar gear wheels. The 2 smaller gears have a difference in their number of teeth. Okay. And magnets are provided in the both of these smaller gears. Okay. These magnets are diametrically magnetized and it rotates above the angle sensors. Now, because the 2 small gear wheels have different number of teeth, they rotate at the different speed. Okay, understand? This difference in rotation creates different angular measurement signals. 2 different type of signals will be appeared. By comparing the 2 measured angular values, the system can measure the actual steering angle. By using these 2 signals, we can measure or we can determine the actual steering angle. This is the basic principle behind the steering angle measurement by using the gear arrangements. The difference in the gear rotation is also useful for obtaining the absolute steering position. This principle is referred to in the presentation as the advantage of this principle is that the system can measure the steering position even when the system is powered on. This provides the true power on or TPO functionality. Already we have seen this feature. In simple terms, when the vehicle electronic system is powered on, the onboard computer can know the position of the wheel. This is an important feature for electronic steering and stability related systems. Now let us look at another design of the steering position sensor. The steering angle sensor measures the actual position of the steering wheel. Okay, this information is increasingly used by different vehicle systems to measure the direction the driver want to vehicle want to move. One important sensing technology used in this sensor, that is Hall effect. Already we have seen about Hall effect sensors, Hall effect principle in previous class. A multipole magnet is fixed to the steering column. Okay. Hall elements are used to detect changes in the magnetic field. Okay. The important advantages of the principle is that the magnetic field can be detected without physical contact between the sensing elements and that rotating magnetic component. Therefore, this is a non-contact sensing principle. Now let us look at the another design of the steering position sensor. The steering angle sensor measures the actual position of the steering wheel. This information is also used by different vehicle systems to measure a driver's direction. Okay. Let us understand the Hall effect based sensing method. When the steering wheel rotates, the magnetic field seen by the Hall elements changes. Two or more Hall elements can be used in this mechanism. The rotary movement generates square wave signals. These signals have a particular phase relationship with the respect to each others. The phase difference between the signals provides information about the direction of the rotation. Okay. Understand? The signals are transmitted to the unit, the control unit, that is electronic control unit. It processes the signals and measure steering position and direction of the rotation speed. Therefore, the sensor provides important information required by the vehicle control system, that is ECU. The control unit also performs another important function. It validates the sensor output signals. For example, it can detect conditions such as a short circuit. This improves the reliability of the overall system. Another advantages of the system, incremental measuring principle, is that the sensor does not require calibration by the vehicle. Okay, this is the one of the advantage. And manufactured in the same way as some other sensing arrangements also. Next one, another major advantage of the Hall effect based steering position sensor, it is a non-contact operation. There is no mechanical contact between the Hall measuring element and the magnetic hub. Because of this, sensor is essentially wear free. This is significant advantage of in automotive applications because the steering system may operate for a very large number of cycles throughout the vehicle's lifetime. Okay, the magnetic sensing principle also provides a resistance to containment such as dust that may enter the sensing housing. Therefore, non-contact magnetic principle contributes to the reliability and durability of the sensor. Now let us look at an important practical feature, that is Poka-Yoke connectors. The term Poka-Yoke means mistake proofing. In automotive systems, connectors need to design carefully because incorrect wiring can lead to malfunction or even damage, or maybe firing can occur. Okay, so the Poka-Yoke feature is provided to ensure that the wire is not reversed or wire is not connected wrongly. Okay, the presentation shows different connectors arrangements including integral connectors, pigtail connectors. The basic purpose is to prevent incorrect connection during the assembly or servicing or any other situation. We can connect wrongly. Okay, it prevent incorrect connection during the operations. Therefore, Poka-Yoke is an important design feature for improving the reliability and preventing human errors during installation. Okay, same time, Poka-Yoke is an important connecting method to prevent accidents also. Next, we can see about sensor test standards. Automotive sensors must operate reliably under different operating conditions. It may be temperature, it may be cold condition, it may be high temperature conditions. There are many different operating conditions are available. So therefore sensors are subjected to appropriate testing to verify their performance and reliability. Testing is important because automotive sensors are continuously exposed to the real world operating condition like dust and same time water and rainy conditions, high temperature conditions. So many continuously exposed real world operations are available. So the objective of the testing is to ensure that sensor provides reliable output throughout the lifetime. Okay, it is intended to operating also lifetime. The next topic is electrical protection. Automotive electronic systems must be designed to handle electrical disturbances and abnormal conditions like high voltage protection, reverse polarity protection, short circuit protection, and ESD. ESD means electrostatic discharge protection, mainly electromagnetic interference protection. These are all the sensor protections from electrical hazards, electrical short circuits. Therefore, appropriate electrical protection is required for sensors and their associated circuits. The purpose of the electrical protection is to ensure reliable sensor operation and protect the sensor and electronic control systems against the undesirable electrical conditions. Like this is especially important in automotive applications because sensors are connected directly or indirectly to the electronic control unit, that is ECM or ECU. In this lecture, we have learned about steering angle sensor, fitment, design, and working principle, measuring principles, and true power on or TPU functionality, Hall effect based steering position sensors, and sensor advantages. And mainly we have seen about Poka-Yoke connectors, sensor test standards we have seen, and electrical production circuits also we are all seen about following items. Okay, it will useful to you. Thank you.